Hey guys, welcome to the worked answers for the 2017 Level 2 Algebra paper. Let's get into it. So question 1a, we've been asked to simplify the following, leaving our answer with positive indices. So the first one here, 3 times 4x, and that's inside brackets, raised to the power of negative 2. So the first thing we can do here is get rid of our negative indices. So we can say 3 over 4x raised to the power of positive 2 now. So that's just our negative indices rules. We take the reciprocal, and so it becomes positive 2. And now simplifying this, we've got 3 over 4 squared times x squared, and so that equals 3 over 16 x squared. Okay, so correct answer here gets you an achieved grade. Okay, our next expression here, 16x to the power of 4 over x to the power of 6, all raised to the power of 3 over 2. Okay, so 16x 4 over x to the power of 6, this is all raised to the power of 3 over 2. So what are we going to do here? Well, we split each, basically each term is being raised to the power of 3 over 2 here. So it's 16 to the power of 3 over 2. And then we've got powers on powers, so 4 times 3 over 2. So we multiply the indices in this case. This is over x, this is a 6, so 6 times 3 over 2. Another way of doing it is going ahead and simplifying inside the brackets first, but it shouldn't matter in this case. So we can calculate 16 to the power of 3 over 2. 16 to the power of 3 over 2, that is 64. X, now it's 4 times 3 is 12, over 2 is 6, over x to the power of 18 over 2, so that's 9. And now simplifying this, we're dividing x6 over x9, and so we subtract the indices, so we get 64 over x to the power of 3 here. Just showing that other method, you could have said 16 and our x4 cancels, so it's 16 over x squared, and you could have raised this to the power of 3 over 2. And you'd get the same answer. So, correct answer here, 64 over x cubed. That gives you a merit grade here. So, an early merit. You achieved correct power of x or number. So, either or. So, let's say, yeah, so, I don't know. I guess the 64 would be your earliest achieved. Okay, moving on now to question 1b. It says, fully simplify the expression. We've got this fraction here, 2x squared minus 50, all over 9x squared minus 39x minus 30. So as always, we'll just write out our expression, 2x squared minus 50 over 9x squared minus 39x minus 30. And so here, we're going to be factorising, right? There's not much else we can do. And with these algebra papers, just when in doubt, factorise. So looking at our numerator, we can take a common factor of 2, first of all. Inside the brackets, you've got x squared minus 25. And then on the denominator, we can take a common factor of 3. And inside the brackets, you've got 3x squared. 39 over 3 is 13, so minus 13x minus 10. And we're going to be factorising again now. This is inside brackets. So on our numerator, x squared minus 25, this is, hopefully you'll recognise, so this is sort of a special case, difference between squares. So the factorised form, we don't need to write it out here, let's just go ahead and do it. Factorised form is going to be x plus 5 and x minus 5. So that's the difference between squares. It's good to know that and be able to recognize it in an exam. That's our numerator. And then we're going to factorize this quadratic here. 3x squared minus 13x minus 10. And we can do it the long way. We've got our quadratic solver here. I think we might actually do both methods. Let's just first use your calculator. You've got 3 as the A term, B term is minus 13, C term is minus 10. And so you get x equals 5 and negative, let's write it like this, x equals 5 and x equals negative 2 over 3. And so if we wanted to put this in factored form, basically, we are going to say x minus 5 as a bracket. We could say it equals 0, but that's not relevant here. And for our second solution, you can say 3x plus 2. So that's a quick way of factorizing using your quadratic solver on the calculator. We can show it using the long method. So we would take our quadratic, we would see that the A term is greater than 1, it's 3. So firstly we multiply A by C, so 3 times, that's a terrible 3. 3 times negative 10 is negative 30. So we're looking for two numbers that multiply to negative 30. And the same two numbers add to the B term, which is minus 13, and those two numbers are positive 2 and minus 15. So we would say 3x squared and we split the B term up, so minus 15x plus 2x and minus 10, half our expression, factorize left hand side, so 3x and then x minus 5 inside the brackets, and plus 2 and x minus 5, and you know you're on the right track when those two sets of brackets are the same, and so we can say 3x plus 2 times x minus 5 is a bracket, and we've got corresponding brackets here, right? 3x plus 2 and x minus 5. So that is what we're going to plug into our fraction. 3x plus 2 and x minus 5. And at this point, yes, you will see we can factorize. Sorry, not factorize. We've already factorized. At this point, we can cancel, right? So we can see x minus 5 is common on the numerator and denominator. And so we can go ahead and cancel these two values. And so we end up with 2 times x plus 5. You don't need to expand again. You can keep it in factorized form. We've got on the denominator 3 times 3x plus 2. And here, correct simplification gets you a merit grade. Your achieved is either numerator or denominator correctly factorized. So either it's one of these either or achieved criteria. So I think this step here, numerator or denominator, would get you an achieved. Okay, that's us for question 1b. Let's move on to question 1c. It says, David has mounted a square photo on a square piece of card as shown below. And we've got this diagram here. it says the border around the photo is of constant width. So we could say I guess at this point we could say x width. So at every place, every point, this is the distance of x. Because of this piece of information, the border around the photo is of constant width. Okay. It says the photo has sides of length n-2, while the card has sides of 2n plus 6. If the total area of the border is 200 centimeters, find the width of the border. So we're solving for x here. It says if the total area is 200 centimeters, find the width. So we need to take this area information and create an expression for the area. And so we could say area of the border equals area to A total minus area of the picture. So this is how I like to set up my equations. There's probably other ways of doing it. And here we know the area of the border, it's 200. And we have to insert some side lengths for the total area of the whole shape and area of the picture. Now the first thing to note is area is obviously base times height in this situation. So area total, now it's a square piece of card, that's important, which means the side lengths are the same and it's square photo as well, right? So we've got 2n plus 6 is our base, but it's also our height, so 2n plus 6 we can write. And for the photo, n minus 2 all the way around, so n minus 2. So that makes our job pretty easy, and so we can say 2n plus 6, and you could say put it in binomial form and raise it to the power of 2. I think we could write out the two sets of brackets, so it's going to help us when we're expanding later on. That's our total, and we're subtracting, and area of the picture, n minus 2 times itself. Okay, so we are going to go ahead and expand our brackets, and we should be able to solve for n here. Now, when I talk about expanding brackets, you've got the FOIL method, so we're multiplying first, outer, inner, and last. And so looking at our first bracket here, we can say obviously 200 equals 4n squared. The b term is 2ab, so 24n, I believe, and plus 36. And we'll keep our minus sign, and we'll chuck everything inside brackets. So we've got n squared minus 4n plus 4. Okay, let's just multiply through by -1 to get rid of our remaining set of brackets. So 4n squared plus 24n plus 36, and we've got minus n squared plus 4n, because two negatives make a positive, and minus 4. This equals 200. At this point, we've got some like terms. So we're going to collect like terms. We've got our n squareds, our n's, and our single like integer values. And this is, the 200 is included in that as well. We can see a quadratic forming, and so let's bring everything to the same side. and put it in ax squared plus bx plus c form, so quadratic form. And so we're going to say 0 equals, we've got 3n squared now. 24n plus 4n is plus 28n. And then 36 minus 4 is 32, minus 200, and so it becomes minus 168. So you could spend time doing this factorizing manually. It would be quite difficult though. Let's use our quadratic solver. A term is 3, B term is 28, C term is minus 168. And you come out with x equals, n in this case, isn't it? N equals 4.15, and minus 13.49. Okay. Now, we still haven't decided what our width around the border is. We said it was this variable x. It's not n, so we can't say it's like it's n equals 4.15 and that's the constant width of the border. But we can come up with an expression for x. And so let's look in red pen. Let's look at this region here, right? X, we've got x and x. We've got n minus 2 in the middle, and we've also got this long length, 2n plus 6. And so here, basically, we can say that this set of working, x plus n minus 2 plus x equals 2n plus 6. And so we're going to solve for x here, remembering that we have a value for n. So we can say, what did we have? It was x plus, what was it, n minus 2 plus x. That equals 2n plus 6. And so just tidying this up, we've got, I guess we could say x equals, we bring our n minus 2 to the right hand side, so it becomes n, 6 plus 2 is 8, n plus 8, and this is 2x, and so x therefore equals n plus 8 divided by 2. So we can substitute for our value for n. Now n is going to be this positive value, so negative, not negative 13.49, but 4.15. Remembering that we are working with side lengths here. So we can say x equals 4.15 plus 8 over 2, and just calculating this, you've got 4.15 plus 8 over 2, and that is 6.075. The marking schedule gives it as 6.1. Okay, now why only the 4.15? Again, we're working to a context, we've got some constraints. Obviously, you're talking about side lengths, and so if we had, for example, looking at this n minus 2 in here, or even that 2n plus 6, if you were to have n equal negative 13.49, none of those dimensions would work. You'd have negative lengths. They have to be positive. Okay, and so here x equals 6.1. So that gets you an excellence grade. Your merit both solutions of the quadratic found. So this step here, and your achieved sets up a quadratic or finds expression for width in terms of n. So sets up a quadratic is probably our achieved. So I guess the step, possibly the step here, maybe right at the start. I can't quite tell. It just says sets up a quadratic. And that other part finds expression for width in terms of n. So yeah, possibly that's something you did right at the start. And so this would get you an achieved. Okay, moving on now to question 1D. It says a teacher has hired a school bus for $560 on a day trip with students. Cost of hiring the bus is to be shared equally between the students. Okay. At the last moment, 3 of the students were unable to go. As a result, the cost to each of those who did go was increased by $1.50. How many students finally went on the trip? So let's say we have to come up with some variables and some equations. So let's say first of all x equals the number of students who went on the trip, right? Number of students who went. Now, I want to look at, well, let's work through it methodically. We've got hired a bus for $560 for a day trip with students. And if the cost of hiring the bus is to be shared equally between the students, then you've got sort of your base equation is 560 over x. That's the idea here. But it says at the last moment, 3 of the students were unable to go. As a result, the cost to each of those who did go was increased. That's another concept. So less students, let's say, less students equals bigger costs. Bigger costs. Okay. And so we're talking about this 560 over x. That is true for the second part, when the students had decided 3 were unable to go. If we say that x is the number of students who went, then 560 is afterwards. What about before, when we had those 3 students? We were going to say it was going to be 560 over, and using the same variable x, it would be x plus 3, right? Now, where are we going with this? Well, we've said less student equals bigger costs. We could also say, if we think about the cost to each of those who did go, it was increased by $1.50. So the difference here is basically difference or increase, whatever you want to call it. Difference was $1.50. And so what is the difference? Well, the difference is bigger cost minus smaller cost. And so less students was the bigger cost. Which one was the bigger? 560 over x or 560 over x plus 3? Less students is the bigger cost, so 560 over x. And we can even write that first of all. Difference is bigger cost minus the small cost, because that's what produced this extra $1.50. And so we're going to say, I hope that made some sort of sense. This is just the thought process on our way to establishing an equation. So 560 over x over 560 over x plus 3. And this equals $1.50. That's going to be our equation. Okay? Now, honestly, doing this question in an exam, and if I'd never seen it before, like, that's difficult to come up with. Anyway, we're going to be solving for x here. So we can cross multiply. So we're going to multiply diagonally, and we're going to multiply our denominators. So we come up with 560 times x plus 3 minus 560 x, and this is all over. We're going to be combining the fractions into one single fraction straight away. You could take an extra step and write out each denominator, but they're the same because we're going to say x times x plus 3. That's our common denominator. And it equals $1.50. Okay, expanding our brackets, we've got 560x plus, now 560 times 3, we can calculate 1680 minus 560x over, expanding our brackets, x squared plus 3x. This equals $1.50. Okay. How much room have we got here? Okay, so we can do a few things at once. First of all, we can cancel this 560x minus 560x. They can cancel straight away. We're going to bring our x squared plus 3x to the right hand side. So we're going to be multiplying by x squared plus 3x on both sides. And so we end up with 1680 equals 1.5 x squared plus, now 3 times 1.5 is going to be 4.5, so 4.5x. And we can see a quadratic forming. Let's bring everything to one side, bring everything to the right hand side just to keep our x squared term positive, is always nice, plus 4.5x and minus 1680. Okay, let's calculate this. And I don't think I mentioned, just if you didn't know, on your calculator, mode, number 5 for equation, number 3 for quadratic solver. And so you can just input the values for A, B, and C. We've got 1.5, 4.5, and negative 1,680. And we come out with x equals 32 and negative 35. And immediately we say, it's a little bit like the previous question, x can't be negative. Obviously you can't have negative people, negative amount of people, and so x, we'll say x does not equal negative 35. Let's rewrite this 3. And x equals 32. Is there anything else we need to do here? I don't think so, because we said x is the number of students who went on the trip here, and that's what we were trying to find, how many students went on the trip. And so here, correct solution, 32 students is going to get you the excellence grade. Your merit quadratic equation formed, so this step here, and achieved if you set up the equation, our initial equation, here, we'd get unit achieved. Okay, I think that's us for question 1. Let's move on to question 2 now. So, question 2a, say solve the following equation for x. So we're dealing with logs here. Log 2x equals 10. Log base 2x equals 10. And so hopefully you would know your log rules going into this test. We can say 2 to the power of 10 equals x. And therefore x equals, 2 to the power of 10, that is 1024. Okay, so achieved for this, correct answer. Second one here, question B, solve the following equation for x. Log x 49 equals 2. So it's actually the same principles here. We can say x squared equals 49. Let's just scroll down. Therefore, x equals, the opposite of squaring is square rooting, so the root of 49. And so x equals plus or minus 7, but that's not true because you cannot have a negative base for your logs, and that's what they're getting at when they say justify your answer. So we'll say x can't be negative, and so x equals 7, let's say 7 only. And the marking schedule actually, so probably justifying it a little bit better, you could say base can't be negative. Okay. So here, correct answer with justification gets your merit. Your achieved is written in index form, so I guess this step here gets you an achieved. Okay. Question 2c now. It says find the value of log. Base is root 5. And inside the brackets 1 over 125. Okay, so log root 5, and it's 1 over 125. Okay, so what we can actually say is that this equals x, and so here it becomes a little bit easier. We use our log rules again, and so we're going to say root 5 to the power of x equals 1 over 125. Now, we can take log of both sides at the same time. Actually, no, let's take log of both sides first. So it's log root 5 to the power of x equals log 1 over 125. And so another one of our log rules, if something is being raised to the power of x, we can actually say x is a factor here. We can say x log root 5. That's another way of writing it, equals log of 1 over 125. And so we can solve for x here. X equals log over 1 over 125 over log of root 5. So this is how you do it algebraically. We can calculate it. We've got log over, it's a fraction, so 1 over 125 over log of root 5, close bracket, and that gives you -6 here. -6. In this case, x can be negative. -6 is the only answer. And so problem solved gets you a merit. You're achieved written in index form again. So I think this step here would get an achieved. Okay. Moving on to question 2D. A computer depreciates continuously in value from 4,699 to 1,500 over a period of 4.25 years. Value y of the computer t years, so we've got some variables here. After its value was 4,699, can be modeled by a function in the form y equals ART. So that's your compound interest formula. You might have seen as well, there's a few different ways of writing it. You could say A equals, obviously the variables change, but it's the same formula, PRT. You might also have A equals P times, another way of writing the rate is 1 plus R over 100. Raised to the power of T. Okay, so we've got y equals ART. And it says find the computer's value after 6 years. So we are finding y. Now what is A? Well, A equals, the value was, okay, so this is actually a two-step question, right? We don't have a rate. If we look at this first little situation here, first sentence, depreciates continuously in value. So in order to find the rate, we have to firstly say, what have we got? 1,500 was our y, equals the initial, so 4,699. Now 4.25, we're finding r. That's raised to the power of 4.25. Okay, so let's solve for r here. First thing we can do is divide 1,500 by 4,699. That equals a nasty decimal. So let's actually rearrange for r and then calculate it all in one. So we can say r equals 1,500 over 4,699, and it's going to be, you could write it as 1 over 4.25, so you're taking the reciprocal of this power here. Obviously you want r by itself. You could also say 4.25 root of all this. Either way, what have we got? Okay, 1,500 over 4,699. It is going to be 0.76 now, is that correct? Okay, yep. So our rate here is 0.7644. And so now we can find the computer's value after 6 years. So again, we've got y equals ART. Just scroll down. And so our original was 4,699 times 0.7644. And what was the time that we were looking for? Was it 6, right? Yes, 6 years. Okay, to the power of 6. And so this is something we can calculate. 4,699 times 0.7644. If you still had that rate as the answer in your calculator, you could go times the answer to the power of 6. That would give you a more precise final answer. Anyway, you get 937.41. Okay, and so here, value after 6 years, marking schedule says 937.26, so that's just rounding errors. Same answer. problem solved gets you a excellence grade here. Your merit value of R found, so this step here, and sets up equation with correct value for A. I guess either of our two equations that would apply to. Let's set up here, gets you an achieved. Okay, moving on to question 2e now. It says, make P the subject of the formula. We've been given this equation here, 81 to the power of px over q minus 3 equals 243. And we're making, let's just write it out. We're making P the subject, right? 81 to the power of px over q minus 3 equals 243. And again, we're making P the subject, so it's going to look like P equals whatever. Okay, so the first thing we want to do here, and actually I'm looking at my notes and I'm looking at the marking schedule. There's a number of ways of doing it. Let's say, now coming from MCAT, going from level 1 to level 2, you would hopefully see that 81 can be written, 81 and 24 that is, can be written in powers of 3, right? So, and let's just list our powers of 3. We've got 3 to the power of 1 is 3, 9, and I actually missed 3 to the power of 3, didn't I? 3 to the power of 3, 4, and 3 to the power of 5, for example. You've got 27, 81, and you'll find that 3 to the power of 5 is 243, not 34, 43. And so I would actually rewrite this and say, basically we're rewriting 3 to the power of 4, rewriting 81 as 3 to the power of 4, and rewriting 243 as 3 to the power of 5. So 3 to the power of 4 to the power of, so this is inside brackets, still to the power of px over q minus 3 equals 3 to the power of 5. And so we've got powers on powers here on our left-hand side, so let's just multiply through. You've got 3, and then it's going to be 4px over q minus 12, right? 4 times 3 is 12. This equals 3 to the power of 5. And so, knowing our base and indices rules, we've got two terms that equal each other. The base is the same, in this case it's 3, and so we can actually cancel the base and say the powers that they're raised to must also equal each other. So 4px over q minus 12 equals 5, and so we can solve, or not solve for p, but we can rearrange for p here, and we can say 4px over q equals 5 plus 12, so 17, not 4pq, 4px that is, 4px equals 17q, and we're almost there, 4p, we're just doing it in steps here. We've got x, so we can say 17q over x. And then lastly, p equals 17q over 4 times x. And so here, problem solved. Correct rearrangement gets you the excellence grade. A couple things, so the marking schedule divided 17 over 4, that equals 4.25. They are equivalent, so it doesn't matter if you leave it just as 17 over 4. And I mentioned they did it another method. They used logs, and they took basically log of 81 and took this indices, px over q minus 3, as a factor. So we did that in an earlier question. and it equaled log 43, and they rearranged for p like that. As I said, either way is valid. And so here, problem solved gets you an excellence. You're achieved, not achieved, merit. They said simplified logs on right-hand side. We didn't use logs. So I guess your merit, I'm just guessing here. Let's just say this is your merit. So cancelling out the base 3. And your achieved converts equation to exponent form. What does that mean for us? Let's say converting to base 3 gets you an achieved. Okay. That's us for question 2. Let's move on to question 3 now. So question 3a, it says the quadratic equation 4x squared plus bx minus 5 equals 0 has solutions of negative 1 over 2 and 5 over 2. Find the value of b. So we've got this equation here, 4x squared plus bx minus 5 equals 0. And again, we're trying to find the value of b. If it has solutions of negative a half and 5 over 2, we could say x equals negative 1 over 2 and 5 over 2. Okay, and what we did before is say, looking at our first solution here, negative a half, 2x equals negative 1, and 2x plus 1 equals 0, becomes a factor, right? 2x plus 1. So similarly, we could say for our second solution now, 5 over 2, 2x equals 5, and so 2x minus 5 equals 0. And this is another factor. And so if we've got two sets of brackets here, basically this is the factorized form of this quadratic. We are going to expand these brackets and hopefully find the value of b. So we've got 4x squared minus 10x plus 2x minus 5, and just tidying this up, we've got some like terms in here. 4x squared, minus 10, this is x in here, plus 2x is minus 8x, and minus 5. And you can actually see, so the terms correspond here, right? You've got 4x squared, the bx and the 8x, and negative 5 and negative 5. And so we could say bx equals negative 8x. And so you cancel x's on both sides and you end up with b equals negative 8. Okay, so here finds the value for b, gets you an achieved. You could, another way of doing it is taking one of these solutions and substituting it in for x. Basically here, you could say x equals a half, for example. You do this working, solve for b. It equals 0, right? Solve for b, and that's another way of doing it. Okay. Moving on to question 3b. It says, for what values of m does the equation 6x squared minus mx equal negative 3 have two equal roots? So 6x squared minus mx, we'll bring our negative 3 to the left-hand side, put it in quadratic form, so it becomes positive 3 equals 0. And when we see this two equal roots, if we were to draw this, a quadratic with two distinct roots looks like this, right? Roots here and here. Two equal roots, you've got a parabola that touches the x-axis only once. Okay, so there's our solution in there. And straight away, when it talks about nature of the roots, we think of the discriminant, right? And so we are going to say that the discriminant, b squared minus 4ac, in this case, one solution is basically the same as saying 2 equal roots, and so it's going to equal 0. So we can list our values for a, b, and c. A is 6, b is minus m, and c is 3. Okay, so we've got minus m, this is squared, minus 4 times 6 times 3 equals 0. Okay, let's solve for m. We've got m squared. 4 times 6 is 24 times 3, 72, I believe. We can check it. Yep, so it's going to be negative 72 equals 0. We can solve for m. M squared equals 72. So m equals plus or minus the square root of 72. And what is that? 72, 6 root 2, so 8.49. Plus or minus 8.49 here. By the way, you could, at this step here, you could factorize and say difference between squares and go m plus the root of 72 and m minus the root of 72. Okay, now is this our final solution? Yep, looks like correct values for m, plus or minus 8.49 gets you the merit grade here. You achieved correct substitution into the discriminant and set to 0. So this step here gets you an achieved. Okay, moving on to question 3c. It says find the values for k for which the expression kx squared minus 12x plus 5 is always greater than 0. Okay, so it looks like we might have another discriminant question here. Let's write out our expression kx squared minus 12x plus 5k. Okay, and before we had, this is my Cartesian graph. We talked about this. This is 2 roots. Here, the discriminant, let's say triangle, right, delta, was greater than 0. We also had the 1 root, or 2, what was the phrasing of that? Same solutions, right? 2 equal roots. Basically, it touches the x-axis once in here, and we set the discriminant equal to 0. And so the third situation is obviously discriminant less than 0. And what is our parabola doing when that is the case? Well, when the discriminant is less than 0, we've got no roots. So basically, if we say this x-axis here is y equals 0, the parabola is always above 0. And that's what they're getting at with this question here. Yeah, so when is this expression always greater than 0? So we are going to set our discriminant b squared minus 4ac being less than 0. And we're going to solve for k. So our a is k, b is minus 12, and c is 5k. Let's substitute these values in. We've got minus 12 squared minus 4 k, and c is 5k. If you'd write it like this, 5k. And this is less than 0. Okay, so 144. And it's going to be minus 4 times 5 is 20, k times k squared is less than 0. So this is similar to the question before. Solving for k this time, we can say 144 is less than 20k let's divide by 20 on both sides. So 144 over 20 is 36 over 5, which is 7.2, is less than k squared. We can take the root of 7.2, and what is that going to be? Plus or minus 2.68. 2.68 is greater than, is less than k. Now, just looking at that does not make sense, because k cannot be greater than positive 2.68 and negative 2.68 at the same time. So we actually have to go ahead and graph our discriminant now. And so we've got our plane here. Let's look at this step in here, 144 minus 20k squared. So it's a parabola, and it's actually an upside down parabola, right? Because of that negative. And so it looks like this. Now, we are saying, according to, again, this step in here, we want values for k when the parabola is less than 0. And so less than 0, we can draw our yellow line once again. This is y equals to 0. Less than 0 is going to be the blue region in here. So we're looking for all the values for k that satisfies that blue region, basically under the x-axis. And we know our roots. They are plus or minus 2.68. Yeah, so I said x-axis. This is the k-axis in this case. Our roots are negative 2.68 and positive 2.68. And so this is y and this is x. If we are wanting, again, values for k below the x-axis, it is going to be k is less than negative 2.68 and greater than positive 2.68. And we can just look at the graph to confirm it. Note how you've got negative 2.68 in here, all the values for k less than that number, so left on the x-axis, in this case it's the k-axis, satisfy their blue region. Likewise, all the values greater than 2.68 or right on the number line satisfy the blue region again. Okay, so this range of values for k is actually the correct answer here, and that gets you an excellence grade. Your merit finding negative 2.68 and 2.68 gets you a merit, so up here, and you're achieved recognizing the graph is above the x-axis with the discriminant set less than 0. So just stating this gets you an achieved. Okay, I hope that makes sense. And let's move on to question 3D now. So it says, write this expression 9 over x squared minus 9 plus 3 over 2x plus 6 is a single fraction. So we've got two fractions here, and it says write it as a single fraction in its simplest form. Okay, so 9 over x squared minus 9 plus 3 over 2x plus 6. Now, you might be inclined to go ahead and cross multiply straight away, right? But just looking at our denominators, you'd end up with some x cubed terms. It would just be like quite difficult. I think you could do it, but the first thing we can do here is actually factorize. So we can say 9 over, and this is difference between squares again, x plus 3, x minus 3, plus 3 over, and we can take 2 as a common factor in this denominator here, and it's going to be x plus 3. Okay. And so if we're talking about writing these two fractions as a single fraction, we need our denominators to be the same because we're adding, right? At the moment, they are similar. They've got this x plus 3 term, but they're not the same. So we can actually multiply by something on top and bottom, multiply each fraction, so we've sort of got two different fractions here, and make them have the same denominator. So I'm going to say with this first fraction, 9 over x plus 3, x minus 3, I'm going to multiply it by this 2 in here. So 2 over 2, what we have to do to the top, we have to do to the bottom. And you've got, for our second fraction, we're going to take this x minus 3 and we're going to multiply x minus 3 over x minus 3. Okay? So let's just go ahead and do that and see what we come out with. We've got 18 over, and we'll keep it in factorized form for now. There's no need to expand. 2 times x plus 3 and x minus 3. And you've got plus, it's going to be 3x minus 9. And in the denominator, just like that, you've got 2x plus 3, x minus 3. So our denominators are the same now, and that means we can combine into a single fraction. We've got, let's say, 3x, and then 18 minus 9 is plus 9 over 2x plus 3 and x minus 3. Okay, now we're not completely done. We have got a common factor in here. We can factorize our numerator. We can say 3 and then x plus 3. That's our numerator, and our denominator remains unchanged for now. And so we can say we've got x plus 3 as a common factor. And so we can cancel that out. And so we're left with 3 on the numerator over 2 and x minus 3. Again, it doesn't matter if you expand or keep it in factorized form here. And that is our correct answer. So this gets you a merit grade. You achieved lowest common denominator found. So I think they're referring to our denominator work. So in here somewhere, we'll get you an achieved. Okay, moving on to question 3e now, the last question of the paper. It says, find the values of m, which the equation 2 to the power of mx minus 3 equals 8 to the power of x squared has exactly one solution. So looking like another discriminant question here. With some added steps. We've got 2m x minus 3 equals 8 to the power of x squared. And so first we actually have to use our indices rules before we can get on to any discriminants. Earlier we talked about the 81 and 243, and we used 3 to the power of 4 and 3 to the power of 5. Here, you should be able to recognize that 8 can be written in base 2, and that's exactly what we're going to do. So our left-hand side remains unchanged for now. And we're going to say 2 to the power of 3, and let's just multiply straight away. 2 to the power of 3x squared it is. Okay. Now, again, same base, they equal each other. We can cancel the base. And so we've got mx minus 3 equals 3x squared. Let's bring everything to one side. We'll bring everything to the right-hand side. Keep our x squared term positive. 3x squared minus mx plus 3. And so this is our equation here. It's asking when, or for what values of m. Doesn't have exactly one solution. Again, we can draw it. One solution looks like this, where the solution is here. And so the discriminant, b squared minus 4ac, equals 0 in that case. So we've got minus m squared minus 4 times 3 times 3 equals 0. So m squared, what is it? Minus 12 times 3 is minus 36 equals 0. This is difference between squares. M plus 6, m minus 6 equals 0. And so therefore m equals minus 6 and positive 6. And I don't think we have to do any further working in this case. Yep, looks like m equals 6 or negative 6 is as far as we need to go. And that is our correct answers here. So correctly solved gets you actually an excellence grade here. Merit substitutes and makes discriminant equal to 0. So this step here, I think, will get you a merit. And your achieved changes the bases to 2. So our first step gets you an achieved. Sweet, and I think that is us for the paper. Yep, so actually a pretty manageable paper. Covered all the bases, logs, compound interest. You had some geometry in there. Discriminant. I think the hardest was possibly the excellence question in question 1. This students and cost of the trip question. That one was difficult. Apart from that, yeah, pretty straightforward. And I hope you guys enjoyed. And I will see you next time. Cheers.